In today's session, I am going to discuss redox reactions, one of the important topic, oxidation states. Oxidation states, periodic classification 3, part 3, already I have uploaded. Each and every group I have explained, and what is inert pair effect, exceptional cases, everything I have discussed to students. Please go to the periodic classification part 3 and then come back to this one. Then it takes less time to understand the points, and after listening all the points, definitely it is very easy to work out questions in our related books, whatever you are following books. Okay. Now, redox reactions, oxidation states. First, I have written some rules. Okay, to save our time. First, look into first rule. Rule 1. Algebraic sum of oxidation states of all atoms of a given neutral molecule is must be equal to 0. Must be equal to 0. See students, I am giving one example to you. Okay, so suppose the familiar example, we can take NaCl, sodium chloride. Sodium chloride. So here, what they're trying to say in rule number 1, one is metal, another one is non-metal. The total compound value, they had given points here. Algebraic sum of oxidation state of all atoms of a given neutral molecule must be equal to 0. This is +1 means this is -1, finally gets 0. Whole compound value must be 0 when it is neutral molecule. Neutral molecule. Yes, take another example, students. How you know this is +1? Sodium is first A group element, right? So first A group element, there is no exceptional case. This is definitely +1. Compound value must be 0. Then you will come to know this one, non-metal. Clear? The same way you can try this one. Suppose KCl is there, potassium chloride, sodium chloride, potassium chloride. Okay, see here, this is also first A group element. This is +1, this is -1. That's all. The very easy way you can calculate oxidation speed based on the rule 1. Now, rule 2. Algebraic sum of oxidation state of all atoms of a given ion equal to its charge, given ion. Look into this, students. The most important example I'll give you after completion of the rules. But each rule to understand, I'm giving one example. Okay, suppose if you take example like SO4 2-. Okay, you are going to calculate sulfur. They will underline one element. That element oxidation state we have to find out. So the element which is underlined, maybe you don't know, right? So take it as X. X plus how many oxygens? 4. Majority of the cases 90% oxygens. 90% oxygens. What is oxidation state, students? -2. Remaining 10% peroxide, superoxide, ozonide. Already have written those rules also, and part 3 periodic classification also had explained. Please go through that and start working questions. Now see, 4 oxygens, each oxygen -2, that is equate to the charge. See what I have mentioned, this is ion, yes, anion. Anion means you have to equate to the charge. Even cation also you have to equate to the charge. Then you will get oxidation states. X -8 equal to -2. Then X equal to how much, guys? Yes, plus X. Easy. Like that we can work out questions. Okay. Now next one. Rule 3. Oxidation state of atoms. Rule 3. Oxidation state of atom in elementary form, that is native state. It is not combined with others. Free state. It's not combined with others. See, look into above cases. Chlorine, it combined with what is this? KCl, potassium and sodium. Then it is oxidation state. Definitely it shows some oxidation state. But here elementary state, see, oxidation state of atom in elementary form, that is native state, must be taken as 0. See, it is within the element, See here. So this type of compounds, what we call it as elementary form. In elementary form, oxidation state of the atoms must be 0. Clear, students? Clear? That's it. Now, fourth rule. Oxidation state of alkali metals, lithium, sodium, potassium, rubidium, cesium. Your work is very easy if they have connected first A group elements questions, second A group elements questions. Why? Because first A group elements, second A group elements, we don't have exceptional cases. So it is first A group element, oxidation state plus 1, second A group element, oxidation state plus 2. You have to remember the element name. Okay. Now, next rule. Fluorine, wherever fluorine is there, it must be always -1 according to Pauling scale. According to Pauling scale, what is the electronegativity of fluorine? Electronegativity of fluorine is 4. He is the highest electronegative element in the periodic table. Never shows positive oxidation state. If it shows, that is highly unstable. When you are in second year fluorine compounds like oxacids of fluorine, we are going to learn that existence it has shown according to NCERT textbook, but it is highly unstable. Okay, now that is example HOF, students. In HOF, oxygen -2, this is +1, this is +1. According to NCERT textbook, they had given it is possible compound, but it is highly unstable. It will not exist. If fluorine gets positive oxidation state, definitely that is not existing. Always -1. Even fluorine attached examples also, our work is easy, students. Now, next, another important example. Look into this, seventh one. Hydrogen is 1, valency is 1, oxidation state +1. When it is +1, when it combines with the non-metals, non-metals gains electrons, right, students? This is -1, definitely this is +1. Overall compound value must be 0. See here also hydrogen, here also same thing. But hydrogen combines with the metals. Please make a note, students. Hydrogen combines with the metals. Metals means definitely it is -1. Metal never shows negative oxidation state. Definitely hydrogen takes that charge, -1. Metal ready to lose electrons, right? So that's why whenever combines with metals, it shows -1 oxidation state. That's why hydrogen acts as both metal and non-metal. Hydrogen acts as both metal and non-metal. When it is reacts with non-metal, acts as metal. Okay, when it reacts with non-metals, it acts as metal. When it reacts with metals, it acts as non-metal. So, hydrogen acts as both metal and non-metal. Is it clear, students? See, I had given first A group element +1, -1. Second A group element, this is +2 means this is -2. See, students, each hydrogen, 2 hydrogens is -2, but each hydrogen is -1. So, they'll give options here. Most of the students are confusing here only. We are calculating per atom, Okay, keep it in mind. So, next one. I'll show different examples, you'll come to know. So, oxygen 90% cases -2. Other 10% cases peroxide -1, superoxides -1/2 and ozonides -1/3. So, already detailed explanation I had given in the previous video, periodic classification part 3. Afterwards, we'll come back to this one. Then easily you can understand. Next, ninth one, oxyfluorides. Rather than oxides, we call it as oxyfluorides. So whenever oxygen combines with other guys, no, generally we call it as oxides. But here we are calling oxyfluorides. Oxyfluorides. The reason, due to high electronegativity of fluorine. Due to high electronegativity of fluorine, rather than oxides, we call it as oxyfluorides. Clear, students? This is one of the important theory examination questions. Now, see, look into this. Fluorine. What is the fluorine oxidation state? -1. How many fluorines? 2. -2. This is -2 means the total value is 0. Total compound value must be 0. Then definitely this is +2. +2 -2 gets cancelled. Finally, it's 0. But each oxygen +2. Each fluorine -1. right? Here also same logic. Each fluorine -1, 2 fluorine -2, right? So this is -2 means this is the guy, +2. +2 means 2 oxygens, 2 oxygen +2, but each oxygen +1. Per atom, please students, per atom only we have to, per atom only we have to calculate. We have to calculate, or else we have to assign the charge. To confuse the student, easiest questions, but students missing marks, reason behind is hurry, little hurry. So they'll see, they'll give options like this. In O2F2 case, O2F2 case, first option, oxygen oxidation state, they will ask oxygen oxidation state how much? Your option +2, second one -2, third one +1, fourth one -1. What is our exact answer? Is it +2? Wrong. Each oxygen +1. This is your option. So like this, we have to do proper way questions. Very easily we can score marks. Okay. Can I go to the some examples which is frequently asking in exam? First, let's start with the easiest examples. Okay. So first, let me start with the potassium permanganate. So underlined one. I'll give the middle one, some metal. I'll underline here. Okay, right. What is this name? Potassium permanganate. Permanganate. It is purple color. It is purple color. Okay, students, our screen color, purple color. See, now what is oxidation state? How to calculate? Can you guess? See, if you don't know also, I will give you two logics here. The first method is, underlined one you don't know, you can guess it. What is the method? This is you know very well. Potassium. Above cases we have seen no potassium, first A group element. This is 1. How many potassiums are there? 1. 1 into +1 plus X. We don't know, this is X. Plus 4 into oxygen 4. Majority of the cases it is -2 only. 4 -2. This is neutral compound. Equate to the charge. Equate to the charge. That's it, students. 1 plus X minus 8 equal to 0. Then if you bring this side, X equal to +7. Manganese here +7. Clear, students? Like that. Is it easy? Now, +7. We have to mention apparent charge. Otherwise, it is not correct. Valency is nothing but 7. But oxidation state is nothing but apparent charge we have to give. Whether it loss electrons, gain electrons, based on that only will come to know. Okay, now come back to the next one. Second method. This is method 1. Method 1. Towards competitive examination, directly you can calculate like this. KMnO4. How many oxygens here? 4. 4 2s are 8. The 2 minus 8. This is potassium +1. This is +1. This is -8. What is left out here? +7. +7 +7. +7 +1 +8. This is -8. Overall compound value 0. See, easy. You can work out like this. But board examination, we have to follow the method like this. You have to present on the paper like this. Clear? Now, go to the next example. K2 Cr2O7. That is what we call it as potassium dichromate. Okay. Now, calculate oxidation state. What is this, students? Method 1. Method 1. First method. 2 into +1 plus 2x. Here 2 no, here case 1, here 2 only, 2 you can take it. Here also 2, 2x, underlined one, this one. Plus 7 into -2, equate to the 0 because neutral molecule. That's it. 2 plus 2x minus 14 equal to 0. If you bring this side, 2x equal to +12, x equal to +6, right? Each chromium +6 oxidation state. They will give option, first option +12. No, it's wrong. +12 not at all possible. Highest oxidation state of chromium is +6. plus 6. Did you understand? Can you go for second method? Can you go for second method? Potassium dichromate, K2Cr2O7. How many oxygens in our hand? Yes, 7 oxygens. 7 twos are 14 minus 14. This is plus 12. This is plus 2. Remaining is plus 12. Each chromium, 2 chromiums plus 12. Each chromium plus 6. Is it clear? How easily we are working the questions if you know the rules, right? So now I will start little tricky questions, which is most important towards JEE mains and NEET questions. Okay. And one more example. This is also easy. K2MnO4. Why I have selected this one? This is potassium manganate, students. Manganate different, permanganate different, which is in green color. But above one, purple color. This is purple color, our screen color, purple color. Right. So now calculate here also. I am going direct method. What is this competitive examination method I am following? So you people understood, no? So theory examination, how to calculate? Directly I am going. Minus 8 plus 2. This is what? Plus 6. Underlined one. So manganese is plus 6. Clear? 4 twos are 8. This is 2 potassium plus 2 and remaining is plus 6. Easy. Okay, overall compound value must be 0. Clear? Now, fourth example. Look into this. Already we have discussed, and once again I am giving to you SO4 2 minus. See, this is one of the frequently asking questions. Sulfur. X plus 4 oxygen minus 2. And this is ion. You have to equate to the charge. That is the rule, no? That is the rule, no, students? Yes, rule number 2. You have to follow rule number 2. And x minus 8 equal to minus 2. X equal to plus 6. That's it, students. Sulfur is plus 6. Can I give the shortcut method? So for competitive examination, second method, ions, second method. Second method for ions, I am giving C. Starting it will confusion, but once you practice, within 1 second you'll get answer. Clear, students? C. SO4 2 minus 4 twos are. See, sulfur you don't know, you can calculate. 4 twos are oxygen, you know, 4 twos are 8. That to minus 8. Right? This is minus 8. So next, he gained electrons from someone. He gained, then you give it back, no? Then give it back. 8 minus 8 plus 2. What is this? Minus 6. Then what is oxygen? Yes, oxygen here minus 6. Oxygen minus 6 means sulfur definitely plus 6, no? Did you understand my point? I am repeating once again, listen carefully. So 4 twos are 8. The 2 oxygen non-metal minus 8. And here the ion itself saying I have gained 2 electrons. He gained, no, give it back. Plus 2. Plus 2. Losing means plus 2. Give it back. Minus 8 plus 2. Minus 6. The overall oxygen what we got it, how much we got it? Minus 6. This is minus 6 means this is plus 6. You can go for calculation like this also. Can I go to the next example? Yes. NH4 plus. Ammonium ion. Ammonia different, ammonium ion is different, students. Okay. See, look into this underlined one. You can go for both the techniques. You can go for this technique or else what I said, that is also. Four hydrogens. 4 hydrogens means plus 4. He has given or taken. Given or taken. This is just add. What is this? Plus 4, right? So nitrogen, how to calculate? Go for the first method and then you will come back to the second method. Starting, if I will explain second method, you will confusion starts. Okay. X plus 4 into plus 1 equal to plus 1 equate to the charge. That's it. So x plus 4 equal to plus 1, right? So x equal to how much, students? X equal to minus 3, right? That's all. Easily you can calculate. Finally, nitrogen is minus 3. One more logic I will tell you. Among nitrogen and hydrogen, who is more electronegative? Nitrogen 3, and this is 2.1. You are confusing minus charge or plus charge means definitely you can go for like this. Which is more electronegative? Definitely negative oxidation state. Clear? We can apply the same logic here. Can you try this one? Can you try this one? Did you get? Yes. This is plus 4 and give charge. This is what, students? You will get your plus 3. Hydrogen will get plus 3. Hydrogen will get plus 3. This is minus 3. You can go for calculation like this. Okay. So now next question. If you are confusing second method, no, leave it. Go for the first method. Now, next question. Here I am giving CuCl2. CuCl. Okay, next one, past. HClO3. Next, HClO4. Okay, calculate oxidation state. This is -2. This is +2. Each chlorine -1. Each chlorine -1. So students, if you need detailed explanation, once again I am telling periodic classification part 3 you can follow, please. Okay, this is what -1, this is what +1. See, here both are +1 plus minus, both are valency 1. So they'll ask questions like that also. Chlorine here -1, no change. Here 2 chlorines -2, each chlorine -1. Then this is -6, this is +1, this is +5. Okay, so method 1 I am not giving, method 2 only I am giving to cover more examples. Students, each chlorine is +5. Definitely central one only they will ask. Okay, calculating oxidation state. This is -8, this is +1, definitely this is +7. Here, that's it. Now next example. Can you calculate this one? HOCl, hypochlorous acid. Hypochlorous acid. Your oxidation state -2. This is +1 +1. Chlorine possible oxidation states -1 +1 +3 +5 +7. So here, if it combines with more non-metal, no, then it shows +1. Okay, if it is combines with the metal, no, non-metal, like that it can action. Okay, hypochlorous acid. This hypochlorous acid, I am giving one more point. It decomposes to HCl plus nascent oxygen. This is what we call it as, students, nascent oxygen. This nascent oxygen acts as, because of liberation of nascent oxygen, so HOCl acts as oxidizing agent. So next video I am going to upload oxidation, reduction, oxidizing agent, reducing agent, and the most important and more confused topics in redox reactions. Okay, so redox reactions also best videos I am going to do, students. Please listen all the videos and give me comments and like, subscribe our channel. You will get daily updates. Okay, now next one. Yes, we'll take little tricky example, students. See, let's start. Suboxide, carbon suboxide. This is one of the frequently asking questions, C3O2. What is the structure? How many carbons? 3 carbons. How I am writing? C. Carbon. See, 3 carbons I have written. This is oxygen and oxygen. This is the structure of carbon suboxide. Here, average oxidation state of carbon they are asking, and each cases also they are asking. All we can find out. Oxygen here, students, oxygen here -2. So this is -2 means definitely this is +2. Both get cancelled, and this is also same way, -2. This is +2, and middle one, which is the middle one, always oxidation state is 0. It is not combining with others. It is combining with itself. Right or not? So it is with other atoms same. Other atoms are same. Middle is same. So like this type of compound, the middle one always zero. Middle one always zero. It is not combined with others. Here it combines with a different element. We can show. Combined with other elements we are showing, but here it's zero. So what is this average oxidation state is nothing but plus 4 by 3. Right? 3 carbons and 2 carbons plus 2, 0 plus 2. They'll get plus 4 by 3. 4 on 3. Clear, students? That's it. Next, another example, Br3O8. Here structure also they are asking, students, and oxidation states also they are asking. First, let me draw the structure. Br3, you can write like this. How many oxygens in our hand? 8. 1, 2, 3. The same way here. 1, 2, 3. Left out here 2 oxygens. That's it. This is Br3O8 structure. Is it clear? Now go for calculation of oxidation states. This is, you can go another technique also, students. See here, this is -2, -2, -2. 3 2s are -6. This is +6. Right? To balance this negative charges, this is +6. Here also same story, -2, -2, -2. This is what? +6. Clear? But here you cannot write 0. You cannot write 0. Why? Because here it will not combine with others. Only with this similar atoms. That's why 0. But here it is combined with others. No? That's why I have selected this example. This is -2. This is -2. What about this guy? +4. +4. Okay. So what is the average oxidation state here? Can you calculate average oxidation state? Br3O8. Yes. How many? +6, +4, +6. Right? How much, students? 10 plus 16. 16 plus 16 by 3. 3 bromines. 3 bromines. Clear? That's it. Or else you can go for our normal method also. Here take it as 3x. 3 bromines, 3x plus 8 minus 2. Each oxygen minus 2. That is equal to the 0. 3x minus 16 equal to 0. Then x equal to 16 by 3 plus 16 by 3. That's it, your answer. Clear? Any method you can follow. But these two are frequently asking questions in competitive exams. Okay. Now, next example. Na2S4O6. Na2S4O6. Or else you can take it as H2S4O6. Both are same. See, I can show this one. Right expanded form. How many oxygens in our hand? So total is 6. 2. I have written here. Another sulfur. See. Another sulfur also same story. Here 2 oxygens connected with 2 hydrogens. That's it. Now see how many sulfurs here? 4. 2 gone. Okay, and how many oxygens here? 6. 1, 2, 3, 4, 5, 6 gone. 2 hydrogens gone. Rest left out is sulfur. Left out is sulfur. This is sulfur connection. Clear, students? Same thing. Now go for calculation of oxidation states. Can you try this one? Can you try this one? The normal oxygen. This is normal oxygen. How you know? It has multiple bond. Double bond oxygen is normal oxygen. -2. -2. This is not normal oxygen. This is C. This overall you can take it charge. Overall you can take it as charge. Easily you can calculate. This is what? -1. Here also overall oxidation state -1. Here -2. Here -2. Each and every atom which is there in H2S4O6 they are asking. That's why I am writing. This is 0, 0. Right? This sulfur, can you tell? If this sulfur they are confusing, that's the reason I am giving one logic here. How many bonds? 1, 2, 3, 4, 5, 6. Right? How many bonds, students? 6. But here only 1, no? Okay. If you go for like this calculation also easy. This is -2, -2, -1. minus 5. This is plus 5. This is also minus 2, minus 2, minus 4. This is minus 1, minus 5. Did you understand? Minus 2, minus 2, minus 1. Totally minus 5. This is definitely plus 5. You can go for calculation like this. Clear? Now, average oxidation state. Average oxidation state. You can calculate. You can calculate. What is the answer? Can you tell? This is what? Plus 5, plus 5. 4 sulfurs. You can calculate. Plus 5. Anyone got answer? Plus 5, plus 0, plus how much? 10 by 4. Plus 10 by 4 means 2.5 oxygen. So each sulfur, average oxidation state of sulfur, many times they asked this question. See students, same here also. But instead of hydrogens, you can write sodiums. That's it. Here hydrogen is easily replaceable. Whenever metals will combine slow, it will come and attack here. Sorry, here, this is the structure I am writing. Go for calculation, the same one. You can try. Okay. Instead of hydrogens, I have written sodiums. That's fine. Whenever metals combined, coming and approaching, definitely who will give the space? Hydrogen. Why? Because these hydrogens are easily replaceable hydrogens. Why? Because it is attached to more electronegative atom. No, is attracting electrons towards itself. Such a way, bond between oxygen and hydrogen is weak. He is fastly losing. Then sodium will come and attack. Here also sodium will come and attack. Same thing. This example they are asking, this example also they are asking. This is what we call it as sodium tetrathionate. Many times they ask this example in competitive examination. Here also sulfur average 0.5. Clear? In similar way. Just instead of hydrogens, you can write sodium. Clear students? Now, next one. Yes. Bleaching powder. Bleaching powder. CaOCl2. CaOCl2. See, like this we have to write. Don't go for calculation like this. Now onwards, I am giving all most and exceptional cases. Okay. See, this is plus 2 students. Minus 2 cancel. Then this is minus 1. This is plus 1. Right? So here chlorine, 1 chlorine plus 1, 1 chlorine minus 1. This is one of the most important example. Now, next question. Next, CrO5. CrO5. This is also one of the most important question. This is butterfly structure. So if you calculate oxidation state directly, so this is what students? Minus 10. This is plus 10. Chromium plus 10 never exhibit. Highest oxidation state is highest oxidation state means your calculation is wrong. But how to do this one? How to do this one? So if you are getting more than group number oxidation state means definitely those are all molecules having peroxy bonds. Peroxy is nothing but more than one oxygen. See, butterfly structure. CrO5 is butterfly structure. Butterfly structure. Clear? C. Like this. Cr. Can I write? Oxygen. Oxygen. This is oxygen. How many oxygens gone? 4. Next. That's all students. This is your CrO5 structure. How easy it is? See, minus 1 peroxy, no, minus 1, this is minus 1, this is minus 1. This is normal oxygen, double bond, no, minus 2. Overall, how many negative charges? Minus 6. Minus 2, minus 3, minus 4, minus 5, minus. Then definitely chromium is, yes, plus 6. See students, you are getting highest oxidation state means they will give options like this. Chromium oxidation state. First option plus 10, second option plus 6, third option both 1 and 2. Something they will give. What is the correct answer? This one. Peroxy bonds Suppose you are getting more oxidation state, means highest oxidation state of that particular element, you can select your answer. Okay. To understand more, I am giving one more example. H2SO5. This is what we call it as Carros acid also. Here if you calculate directly -10, this is never exists. According to group number, what is the sulfur? It is 16th group, that is 60A group element. The maximum oxidation is +6. Then you go for answer +6. Clear what I said? Above example, same. This peroxy bonds, we are getting more than group number oxidation statements. Definitely it has peroxy bonds. How to write? So look into this. Sulfur, S double bond O, S bond O. So how many hydrogens here? 5. 1, 2, 3, 4. Right. So one more. You can write like this. Don't write that OH. OOH. This is peroxy. Peroxy. More than oxidation state here different. Okay. See here 1, 2, 3, 4, 5, 6. This is sulfur, highest oxidation state. That's it. This peroxy bonds oxidation state calculating it's different. Okay, based on structure, we have to give the charges. Clear, students? Okay. Now going to the next one. NH4NO3. NH4, we call it as ammonia. Okay. So here they are asking average oxidation state. Average oxidation state. But two nitrogens, they know how to calculate. Go for the same method. Two nitrogens, no, take it as 2x. Plus how many hydrogens? 4. 4 into plus 1 into oxygen equal to the 0. 2x plus 4 minus equal to 0. 2x equal to how much, students? Yes. 2x equal to 2. Each nitrogen is clear. That's it. Okay, but actual structure, based on structure also you can go. This is ammonium nitrate. How it can dissociate NH4 plus NO3 minus. Clear? Based on this also you can go for calculation. You will get oxidation state. Anyone calculated? Yes. I'm giving answer. Check it. Yes. This is equal to the charge. X. This is X. This is X. X plus individual cases you can. X plus 4 into plus 1 equal to the charge. X plus 4 equal, then X equal to minus 3. This is what NO3 minus. X plus 3 into minus 4 minus 1. Then X equal to oxidation is nothing but how can get minus 3 plus 5 by 2. How much, students? Minus 3 plus 5. That is 2. Okay. Like. And I am giving one more example. Please everybody try this one. Me. And next video I'll give the another example. If I'll go for additional questions, high order questions as of now, you'll get little confusion. First you prepare all these topics and next periodic classification part 3 also, then get ready for the high order questions. And H4NO2. What is this? We call it as ammonium nitrate. Next video I am going to ammonium nitrate and acetaldehyde and acetic acid. These 3 examples, try oxidation state, average oxidation state. If you go for first method or second method, your wish, try it and comment me answer. Thank you, students. Thanks for watching. And the coming days, I'm going to do more useful videos and short tips also. Definitely it is useful and very helpful during examination. Please subscribe our channel. You will get daily updates, students. So as many as students you can inform and share to others also. Definitely all the people get benefit. We all very happy end of the year. Okay, students. Thank you. Thanks for watching.